Okay, today we're going to go over section 2.3, which is polynomial and synthetic division. It's how you divide quadratics. So, look at example 1. We have x minus 2 is dividing into 6x cubed minus 19x squared plus 16x minus 4. Okay, so we're going to start by doing this the long division way so that we know how it works, so that then we can learn how to do synthetic division. So we're always looking at our first term, so we try to figure out how many times x will go into 6x cubed. So if we divide x into 6x cubed, we end up with 6x squared. And so we're going to take this x minus 2 times 6x squared. So x times 6x squared gives me 6x cubed. And 2 times 6x squared gives me minus 12x squared. Okay, and then we're going to subtract this whole thing from the top, because that's how long division works. So 6x cubed minus 6x cubed cancels. Negative 19x squared minus negative 12x. So this minus a negative actually becomes a plus. And so this becomes negative 7x squared. And then we bring down our plus 16x. Okay, so the next thing then that we look at is how many times this x will go into this negative 7x squared. So 7x, so minus 7x. So x times negative 7x is negative 7x squared. Negative 2 times negative 7x becomes 14x, and it becomes a positive 14x. And then we're going to subtract this whole thing from the top. So negative 7x minus negative 7x becomes 0. Those cancel. 16x minus 14x is 2x, because 16 minus 14 is 2. And then the last thing that we bring down is that minus 4. So the last thing we have to look at is how many times that x will go into 2x. So it'll go in there 2 times, so positive 2. So x times 2 is 2x. 2 times 2 is 4. And if we subtract those, 2x minus 2x cancels, negative 4 minus negative 4 cancels, and we end up with 0, which is what we wanted. We want a remainder of 0 when we're doing this. So then our final answer is going to be 6x squared minus 7x plus 2. Okay, so let's look at 1b. We're dividing x cubed minus 2x squared minus 9 by x minus 3. Okay, and we always look at our first two terms, so our x and x cubed. X goes into x cubed, x squared times. So x times x squared is x cubed. Negative 3 times x squared is negative 3x squared. And then we subtract this whole thing. So x cubed minus x cubed cancels. Negative 2x cubed minus negative 3x minus a negative actually becomes a plus. And so this would become 1x squared. Then we bring down our minus 9. X goes into x squared, positive x times. So x times x is x squared. 3 times x is 3x. Then we subtract these. Those cancel. We can't subtract a 9 and a 3x. Negative 3x minus 9. You could also write it negative 9 minus 3x, but since we care about our x's, that's why I put that 3x in the front. So then we look at how many times this x will go into the minus 3x, and it will go in there minus 3 times. So x times negative 3 is negative 3x. Negative 3 times negative 3 becomes negative 9. And then we subtract. Those cancel, we end up with 0. which is what we wanted as our remainder, so we know that our final solution is x squared plus x minus 3. Okay, sometimes an easier way to write that would be when you include zeros for your missing term. So this is like x cubed plus 0x squared plus 0x minus 1. Because we don't have any x squared terms and we don't have any x terms. So I'm going to take that and I'm going to divide that by x minus 1. Because then at least I'm representing my missing terms. Okay, so then if I do that, x goes into x cubed, x squared times x squared is x cubed, negative 1 times x squared is negative 1x squared. And then if I subtract, x cubed minus x cubed cancels, minus a negative becomes a positive 1x squared, because 0 minus negative 1 becomes 0 plus 1, which is 1. And then I bring down my 0x. Okay, x will go into x squared x times. So x times x is x squared. Negative 1 times x is negative 1x. And I'm going to subtract those again. These then cancel. 0 minus negative 1 becomes 1x. Then lastly, I bring down that minus 1 term. X will go into 1x 1 time. X times 1 is 1x. Negative 1 times 1 is negative 1. And if I subtract, each term cancels and I end up with a remainder of 0. So I know that when I divide, I end up with x squared plus x plus 1. Okay, so that's what you end up with in polynomial division. The easier way to do this is to do synthetic division, so that's what we're going to look at next. Synthetic division is a derivative of polynomial division. Okay, so with synthetic division, you have your divisor k, which is one of the terms that will go into your, that will divide evenly into your function, and then you have your coefficients, a, b, c, and d, and you drop your first coefficient, and then you start multiplying and subtracting until you get a remainder r. And we almost always, well, we always want our remainder to be 0, and that's generally what we'll end up with. Okay, so let's look at this diagonal pattern. So let's look at the polynomial x to the 4th minus 10x squared minus 2x plus 4. And we're going to divide it by x plus 3. The first thing I'm going to do is I'm going to write down my coefficient. So x to the 4th has a coefficient of 1. I don't have an x cubed term, so x cubed out. A squared term is negative 10. Input to exactly 1 value. And my constant term is 4. So those are my coefficients. Okay, then the next thing I do, x plus 3, is going to be my term. So this actually tells me then that x is 3 to be my divisor. Okay, and then we always drop our first term. So drop my 1. Negative 3 times 1 is negative 3, so that's why that goes up into our diagonal pattern, our jagged pattern. So plus negative 3 is negative 3. Yep, and then take negative 3 times negative 3 is a positive 3. For adding down and multiplying pairs, your input-output pairs, check to see if it follows them. And then we multiply that, and so negative 3 times negative 1 is a positive represent. And specifically illustrate
What's using?
Did I miss? Okay, negative 3 times 1 is negative 3. And if we subtract, we get a remainder of 1. Which is not ideal, but we did get a remainder of 1. We prefer to get remainders of 0. Okay, and then these become our new coefficients, and we always draw our exponent by 1. So we started with an x to the 4th, so this becomes 1x to the 3rd. Minus 3x plus 1 with a remainder equal to 1. And that's all you do. I was hoping we would remember. Okay. Let's look at another one. So we have 5x cubed plus 8x squared plus 6, and we're dividing it by x plus 2. Let's start with my code. Squared negative 1x. Constant of 6. And I'm not missing any terms, so I don't have to include any zeros. I'm dividing this by x plus 2, which actually means x equals negative 2, so I'm actually using a divisor of negative 2.
Which just means that the equations would be something like y equals add
that minus negative 2 times negative 2 is 4. If I add those, negative 1 plus 4 is 3.
an even function.
Times 3 is negative 6. If I add those, I end up with 0 as my remainder, which is always what we want to end up with, but not always what we do.
A function f of x.
My new
How can you tell if it's even?
and 3 minus 2x plus 3. And since my remainder was 0, that's completely right. I don't have to write anything about my remainder. Okay, so does this make sense? So more, are we feeling okay? Good? Okay. Here's going to page 156 through 17 and 27 through 33. I think that's only like 9 problems, so we should be okay.